Alright, in this video I want to get an ant. So the thing I'm aiming for here is implementing the ant colony optimization algorithm or family of algorithms. I want to experiment with that. We have our traveling salesman-like problem set up. We just have the basics here. We have a graph and some locations. So it's sort of like cities. They're fully connected. We've calculated the distance between them and stored that as a property in the graph, an edge property. So now I'm just going to get started playing with ants. I'll probably have to change this graph representation that I have as we go along and we figure things out. So let's start hacking away. Okay. So the first thing I was thinking of doing is manipulating my agent here. So the first thing I'm going to do is rename this to ant. I don't really have a great reason for that, but it is an ant after all, so why not? Ant. Okay, and that should, yes, that's percolated through all the references to it. All right. So the first thing I want to do is assign it to a city, initialize it. But now that I think about it, that is placed here in this model. So I don't have to do that. Step. Okay. Well, one thing we want to do is move the ant to another city, right? And then one of the key parts of this is you never go to the same city twice. So we are going to want to keep track and then only choose cities based on them not being there, and then some heuristic. I think in this iteration I'm going to do something very simple and have the ant just sort of deterministically go to the nearest city that it hasn't yet been to. So city list or cities visited. I'm going to make this a set. And now that I'm thinking about this, my ants in this case will be specific to the traveling salesman problem, so I'm going to go ahead and put a reference to that here. So ant TSP, because my ant for some other problem probably won't have this notion of cities. Okay, so cities visited. So essentially I need to choose a random city that is not let me think about how to do this, because as it stands now, this ant doesn't know how many cities are possible or doesn't know the possible city list. So what I would normally do is take that, remove these elements, and then choose randomly from that remaining list, or whatever the heuristic is going to be, closest one, whatever. So I need to think about the data structure and how this is going to be. Oh, the model is passed here. Okay. I forgot that the model is there, because the model is this thing, and that'll have num cities. Okay. So let's see. Since right now my cities are an integer, are integers, I can just get the range up to the number of cities, get a list of that, and that'll be a list of all the cities. Okay, so now the first thing I'm going to implement is just choose a random city and then add it to the cities visited. How do I get what location it currently is in? Where is the network grid? I remember seeing some method about this. Place agent, get neighborhood, get all adjacent nodes within a certain radius. How does the radius work here? Was that just the number of hops away? Okay, that's cool. Okay, move agent, remove agent. So how do I get the current node the agent is on? Remove agent. Oh, .pos. So is that the sort of key thing here? What does place agent do? Oh, okay. So agent.pos. Great. So now, I wonder when this is initially done. So, for example, when this is initialized, it places the agent. Okay. City. Okay, I need to explicitly add this city when this is initialized. Okay, so now the agent has been initialized to this city. It's been added to the city's visited list. Okay, so now during step, I need to, and instead of making this a list, I'm going to make this all cities thing a set as well. Now I can do set operations. Pick a random city that isn't in, okay. New city, self.random choice, self.models all cities minus self.cities visited. And that turns it to a list and a random choice. That seems right. Okay. Move agent, self, Yep, that's the agent, right? Now, is it called grid? Yeah, grid. Okay. Now, for debugging, just for a second, let's see, self.pause. All right, so it should move from this city to, okay, but of course, it will have already updated pause at this point, so I should do this up here. So, moving ant from city pause to new city, and then we actually do the move. Okay. So num agents. For num agents, let's just do 2. All right. Step. All right. Moving ant 1 from city 13 to 8, moving ant 0 from city 12 to 17. Okay. 8 to 14, 17 to 9. All right, so let's see what happens when I click this button a bunch of times and it runs out of cities. It should throw an error about the list being empty or something. Cannot choose from an empty sequence. Okay, cool. So that works. I'm going to add a new method to decide which city to go to. And this is where I can implement something simple, like this random policy or a little heuristic. Okay. Decide next city. Oh, wait. I don't need that. Why does it... I'm not sure why it's complaining about that. Okay. Okay, great. So this is a random policy, right? Choose closest city. So I think I need to get the graph here. So Okay, by the way, something I wanted to fix from last time. I had this graph that I created and stored it as this attribute. But I already have that. Wait, I'm getting lost here. Here, it should be attached to network grid as like a dot capital G here. So I think I can get rid of self.g. And then in my create graph, I'd like to return a graph. So let me just do it. You'll understand what I mean. Okay, so create graph currently doesn't return anything. I'll change that so that it returns the graph. And then I will pass that into the network grid. And then when I want to access it, I'll do self.grid.capital G. So we can eliminate all these self.g's and just make it G. And then we will return G. It's a little ugly to save the positions as this separate attribute, but I haven't thought of a better way of handling that yet, so we will keep it for now. Okay, so we return G, we attach it to the grid. Now, where do we call self.g, if anywhere? Or model.g, do we do that here? Yeah, so we need to do model.grid.g, like that. Let's see if this works. Self.model.g, where is that? Oh, the code I just wrote. .grid.g, okay. We'll put our random policy on for just a second. Reseed, step. Okay, cool. We seem to be back in action. So comment that back out. All right, now we have our network X graph, G. So we want to find the neighbors of our current node. Okay, so current, yeah, city equals self. Let's see here. Is this an actual network X thing? Dot neighbors? Returns an iterator over all neighbors of node n. Okay. So now we need to get the distances for neighbor and neighbors. Neighbors and cities visited. Continue. So we'll skip it. Okay. We will get the distance. Let's see. Whoops. Current city. Neighbor distance. Oh, one thing I need to also fix. I don't think I ever reversed the edges in the graph, so we only have half the edges. So in a previous video, we saw that we had basically half the number of edges we expected in a complete graph. Make undirected. To undirected, okay. If true, only keep edges that appear in both directions. Okay, so it looks like I just have to do this. I'm kind of jumping around all over here, but I need to make sure that I am not excluding edges, or this is going to break. Because if I only have the neighbor current city instead of current city neighbor, then this won't have any information in it. So I need to make sure to fix that real quick. So when we create the graph, which we have this handy dandy create graph method, we should be able to do to directed. I also made another mistake in the last video. I was thinking of this unit square and thinking as long as this distance is greater than 1, everything should be within that radius. But that's not correct, because obviously the diagonal is greater than 1. So, you know, if it's a unit square, then the square root of 2 would be the maximum possible distance. What is that, like 1.7 or something like that? So in this case, it should work. That with 2 dimensions, the maximum is the square root of 2, which would be underneath this maximum value of 2. So I think we're good here. But if we go into higher dimensions for some reason, I don't know why we would, but in that case, we would have to make that the square root of 3. Or wait, it's been a while. In any case, to directed. So before I do this, I want to test something. Print length g.edges. I want to make sure that my, okay, so 380. So that should be 20 times 19, 380. Okay, so now I have all of my edges. If I do this to directed. So let's go ahead and do that here. Wonder how that's going to change this. Okay. Holy moly. All right. Need to get rid of those arrows. Okay, we'll revisit the visualization in a minute. Okay, so here we have our distance from the current city to the neighbor. If distance less than min distance, then overwrite it. New city equals neighbor. Okay, now the other thing we need to do is add a condition to stop if we basically run out of cities. I can't remember how you ask these things to stop. I should probably look at an example. Forest fire. Okay, didn't help. Oh, running. Okay, self.running is true. But that's at the model level. But we basically know how many steps we need to take, right? Is the number of cities. So, create graph, step. So where do I store these agents? I guess I don't. Okay. Check length of cities visited by an agent. Okay. Let's see, when was this setting here? Oh, okay, after this. So I guess after that final step, if this pushes it over the boundary, then it will set self.running equals false. And then presumably that will stop this from being called again. Okay. So far, what have we done? We fixed a few small issues from the previous. We now are choosing the next city based on its proximity. And then, so first of all, we put an ant on a random city, and then it chooses the next city based on proximity. But it can only visit a city one time, and when it gets to the end, it should stop. So let's go ahead and step this. Okay, why didn't that? I don't know why that didn't stop. All right, to make this a little faster, I'm going to make number of cities equal to 5. And then also this visualization I have here of num agents. What I'd really like is num cities visited or something like that. So what was this? Num agents? Maybe I shouldn't worry about data collection right now, because I don't know exactly how it works. because this is at the model level. I'm thinking that I could set number of steps or something like that. Dot num steps plus equals 1, right? Okay, self.num steps equals 0. Now instead of num agents, we have num steps. Num steps. All right, let's see. Where is this coming from? Oh, back here, I think. All right. Num steps. Okay. Step 1, 2. I don't know what the x-axis is here. Ant1 has visited all cities. Okay, so it is picking it up. And set running equals false. Okay, apparently I need to read the documentation of like running your first model, collecting data. Self.running. Okay, so checking out this documentation. An episode does either end when self.running of the model class is set to false, or when model schedule.steps equals max steps. Wait. Okay, so that's to batch run. But how can I set the max steps for a single run? All right, what happens when I just hit play? Oh, okay. So step equals 4. They visited all cities. If I reset, then I can run again. Okay. So at least the if I manually click step, it'll break it. But if I set self.running equals false and I hit the play, it'll sort of automatically stop. Okay. Decide next city. Okay, so where am I excluding? Oh, okay. New city equals none, right? Because this only gets assigned in this case. But if neighbors is empty, okay. If new city is none, then new city equals current city. You have to hold still. Okay. This should at least stop it from breaking. All right, cool. So let's review. We have an ant, and it's placed on a city. It now follows the simple heuristic encoded in this method, which chooses the closest city not yet visited. And that is it. Now, eventually, we're going to want to log what these paths are, of course. And we're going to want to count the distance, total distance traversed.